What's up guys, today I'm up with a very interesting problem. Find from binary search a 2D matrix. So as from the name it is very straightforward. So let's see the inputs real quick. So as per the problem we are given a m into n integer matrix. So as per what they have said as matrix, they should have given us a two in a array, two-dimensional array, just like what I told. Okay, now we are given a two-dimensional array, aka matrix. So each row is sorted in a non-descending order. So as before we even know it, each row is sorted. Okay, so it is sorted in a way that in the last element of each row is smaller than the first element of the next row. So the whole matrix is sorted in this way. Okay, so our task is very simple. We have to search a 2D matrix for a particular target value. Okay, as per this matrix 3 is the target value. We just have to return if the target value is present or not. We don't need to return the index and all. We just need to return true or false if the value is present or not. Okay, so there's a catch. Okay, you can't just like loop to the entire matrix and return. So there's a catch. The catch is you must write a solution in order of log m into n time complexity. Okay, so you have to write an efficient solution for this problem. So that is the catch in this problem. So without further ado, let's get on to the logic. So the logic part is very simple for this problem. So as per told, we're given the target integer, and we're given a 2 into an m into n matrix over here. This is the input. So as we have to just determine if the target value is present or not. Okay, so let's just analyze what are clues that are given. So first thing is we have to search a value in an efficient way. Okay, that is the first clue. We have to search a value in an efficient way. The second clue is that given matrix itself is sorted. Each and every single row is sorted. The last element is lesser than the next row's first element. Okay, if the whole matrix is itself sorted. So the first thing that comes into our minds is to do this in an algorithm called binary search. So that's what we're going to follow. Okay, so binary search, as we all know, it follows a logarithm n time complexity. So we're gonna do this little bit with binary search. Okay, so as I told, the most thing is the target value could be in any row. Okay, we don't know what row it is. So the first, I'll break it down for you guys. So the first part is we have to find the row which the target value is present in. Okay, that is the first part. The second part is we have to binary search through that row and find that element. Okay, that is simple, we know binary search. But for finding the row also, since every element all the rows are sorted here, for finding the appropriate row also we are going to use binary search. Okay, so the logic is straightforward. We're going to use binary search to find the row which the target element is in. Then we are going to binary search the entire row and find the element. Okay, and then return our answer. Simple. So to give a more detailed explanation on our logic, first we're going to binary search through the row. How we're going to do this is similar to binary search. We're going to have a top row, we're going to have a bottom row. What we're going to check is we're going to check if the element is greater than, we're going to have the top row and we're going to have the bottom row. Similar to binary search, we're going to calculate the middle row. So I'll just point it out. So far we're going to have the top row here, top. Let me have it in a nice red color. So let me just put it up here, and we're going to have a bottom row. Then we're going to calculate the mid row. So thing we have to find here is we're going to check if the target value is less than the first element in our mid value. Then it is then if it is less than the first element in our mid value, it is somewhere in the top side of the mid row. Correct. Then we're going to move this bottom row to mid minus 1. Okay, as per how we do in binary search. Okay, if suppose if it is not less now, then we'll check if our current value is greater than the last element of the middle row. If it is greater now, then it is somewhere in the below. So we're going to move our top. Okay, this is exactly. So like I told, we're going to binary search like this and find the appropriate row, and then with that row we're going to do a normal binary search and find the element. Okay, so let's start coding right away. Okay, first I'm going to get the dimensions of the each and of the row and column. So I'm going to get the length of m and n. So I'm going to have a variable called rows, and it's going to be the number of rows there, which is going to be the length of the matrix. Correct. Now I'm going to get the length of the each column. I'm going to have it as calls, and I'm going to get the length of the first element in the matrix. This should give me the length of the column. So since now I got the dimensions, I'll carry on with the first step, finding the appropriate row which the target element is in. So we're going to go do a binary search. So I'll have the top row initial declared as 0. So top row is going to be 0, and sorry for the semicolon, and the bottom row bot, which is going to be our rows, this capital rows minus 1. Okay, we're just going to get the index of the rows itself. So we'll do a normal binary search while our top should be less than or equal to our bot. Correct. Simple. So here what you have to do, we have to check if our target value is, let's check if it is first less than. Okay, so if our target value is less than the our, no, first we'll calculate the middle value. Okay, we'll calculate the middle value each time. So mid, since this is the mid row, I'll have it as mid row. Mid row will be equal to the top row plus bottom row divided by 2. Okay, as per our all, as per we know in the binary search logic. So here we're gonna calculate, we're gonna check if our target is less than the mid row matrix of so we're gonna get matrix of middle row. We check the middle row, it's gonna be capital R, middle row, and then we're gonna check it should be less than the it should be less than the first element. Correct. So I'm going to check middle row of 0. If it is less than I have to just stop using these brackets. So if it is less than then I have to move the bottom, so it's somewhere in the top. Correct. So bottom is equal to mid row, bottom will be equal to mid row minus 1. Correct. So let's say if it is not, if it is exact opposite, if as per we told our target, let me just take this as it is simple. Our target should be greater than, and the should be greater than the last element of the row. If it is greater than the last element, it is somewhere in the bottom. Now since it is somewhere in the bottom row, we have to move our top pointer. Top should be mid plus 1. Okay, if it is not, if it is a not either one of this, we put this as else if it is not either one of this, then it is definitely the thing is in the mid row, so we can just break out of that. Good. So the second thing is, after we break out of there, let's say the target element is not present in any row, it does not match any condition in our in our in our binary search here. Then what you have to do is, if when will that case, that scenario will get executed if the top row if the top pointer just cross the bottom pointer. If the top pointer is greater than the bottom pointer, then there is no such element, there is no such row that has the target element. Correct. So we'll have that condition here. If top is less than or equal to bottom, if this should be always be the case. If it is not this case, if it is not this case, oh, sorry with the bracket, guys. Okay, if it is not this case now, then we just have to return false. Good. So one base case is done. Here the next part is very simple. Now we just have to do the normal binary search on the middle row itself. Okay, mid row. So let's just start with the normal binary search. So I'll have as so I'll get the row here. I'll just calculate the middle row again here. So row should be equal to our target. So sorry, the row should be equal to our top row plus our bottom row. We just have to do this calculation at the first part. Let me just do this calculation in the first part. It should be top row bottom row divided by 2. Correct? Let me get rid of this stupid space here. Yeah, okay. Now since we can have our row here, our middle row, now it's a simple binary search. So I'll have my starting pointer is gonna be it's gonna start at 0. I'll have my ending pointer, which is gonna be the length of the column, which is as calls -1, since it is 0 based indexing. Okay, so I'll start my usual while loop. My start pointer should be less than or equal to my end pointer. As always, here I have to calculate the mid value. Mid is equal to start plus end divided by 2. Correct? After this, let me check if the target is less than T matrix of our row of our mid value. If it is less now, then it should certainly be in the left of the of the array. So I'll move my end pointer. E will be equal to mid -1. I'll move my end pointer, and then if it is not this case now, then I'll just check if my target value is greater than matrix of row of mid. If it is greater now, then I have to move my start pointer to mid +1. That's it. If it is not either of this case, else if I have to put here, if it is not either of this case now, else then it is in the middle. Then our target value is equal to the middle value. Then we can just return true. Good, sounds good. If this return is not coming, if the line is not coming to this return and this else statement is not getting executed now, then there is no such target value. So at the last, if this return is not getting executed, we can just simply return false. Okay, so sounds good, looks good. So let's check if all the test case pass. So all the test case passed. Couple of stupid mistakes I made here. Instead of elif in Python, I put else if. So I recently coded a lot in Java and JavaScript. So that's why the bracket and this else if is coming. So sorry for that. So instead of else if, you have to put elif. And that's the only thing. And we bet 100% of the users. So thank you for watching, guys. See you on the next problem. Bye.